Every delinquent customer at a large utility passes through a similar life cycle. Day 0, something changes. A heat wave drives AC usage higher, or an expired credit card fails in autopay. Then, on day 15, the customer receives the bill. On day 30, the first late notice arrives. Then, on day 60+, the bad debt is written down by the utility. An unfortunate, but all too common set of circumstances. Today, utility collections operations are focused on the back half of this life cycle, days 15 onward. Dunning, disconnects, and hardship referrals all happen after the fact. But what about days 0 through 15? What we call the pre-delinquent window. What if we could use the predictive power of AI and the proactive power of AI agents to act in that pre-delinquent window? That could create tremendous savings, namely $6 to $10 million of avoidable bad debt from card expirations that could have been caught, first-time late payers who could have been nudged, bill shock cases that could have been resolved with installment plans, and general disconnection and reconnection costs. Not to mention significant savings in CSR costs, saved reducing the back-and-forth calls related to delinquency issues. While utilities may have different systems to address these specific issues, there is no intelligence layer that watches over disparate data sources in real time, with the pointed goal of intervening in the window long before a customer ever picks up the phone. That is the gap we built the Pre-Delinquent AI Agent to fill. This is mission control, the page a director of customer operations might use. It could be a standalone page like you see here, or integrated into an existing dashboard, CRM, CIS, or another enterprise user interface. Everything here is happening at a fictitious utility we created called Quintus, where roughly 13,000 events per minute are flowing through the AI agent right now. You can see that in the live agent activity feed. The risk agent watches CC and B and AMI streams to analyze, detect, and flag customers heading toward delinquency. The decision agent picks the best next action for each flagged customer, pulling the unified customer view directly from CC and B. The communication agent formats and delivers communications directly to customers on bill situations and treatments proposed. The payment agent evaluates and recommends payments arrangements and writes them to and from CC and B. Now let's dive into what these AI agents are doing in real time. You see there are 67,450 customers flagged here. 3 are awaiting human review. More on that later. Notice Jane Okafor score 51. Flagged driver was a usage spike plus 42%. Resolved autonomously. Total time 3.2 seconds. All 4 agents involved, 0 human touches. Jane has been flagged by 2 events, the bill spike and a prior bill shock call. The model has learned that customers who've called CSR after past bill shocks are 4 to 5 times more likely to do it again. The decision agent then generated and scored 6 possible treatments, then chose the SMS plus 2 installment plan based on success with customers similar to Jane. When the decision was committed, the communication agent took over. It drafted the text in Jane's preferred method. Now the communication agent and the payment agent execute simultaneously. Quintus delivers the SMS message to Jane. The payment agent calls CCB API and posts it to CCB. 1 minute 47 seconds after the SMS was delivered, Jane tapped through and accepted the plan. Each agent observed the outcome, and the AI agent learned from the success here for future evaluations. That's the autonomous path. 3.2 seconds, 4 agents, 0 humans, full audit. But not every case is as easy as Jane's. Some cases are more complex and will require a human in the loop. And that isn't just where the autonomous agent fails, but rather where a human is required to complete the process as defined by business rules called guardrails. These are the 10 guardrails set up and configured by Quintus to trigger when human approvals are required for the AI agent to take any further actions. So let's look at another customer scenario where those guardrails were triggered. David Carter, residential customer, 4 years tenure, 2 warnings, broken arrangement, and an open dispute. The risk agent flagged him when his score shifted from 73 to 78 on the latest billing event. The decision agent pulled David's profile from CC and B. It evaluated candidate actions. But then, 2 guardrails were triggered. Both are configured as human-required guardrails. This changes how the agents handle David's case. The decision agent's recommendation is to route David to a CSR Tier 2 collection specialist because this is a complex case with a broken arrangement and an open dispute. The decision agent has decided this is the right path. It just needs a human sign-off to execute it. Now, as a human supervisor, I'm going to approve this. Watch what happens with the agents. When the supervisor clicks Approve and Execute, the downstream agents pick it up and executes a series of communications and data transfers. And there's the result. Routed to CSR Tier 2. Callback scheduled. Context delivered. Dispute investigator looped in. Customer notified. 6 steps. About 1.5 seconds of execution time. The next step is a human conversation, not an autonomous action. Reach out to us today to see how rSTAR's pre-delinquent AI agent can lead to significant savings for your organization.